sheetrock sucks. There's
It
just
does. It's heavy and it can get messy. And if you ding it up, then you got to fix those parts.
just all
And then
like
you get,
I used 3 buckets of mud, and it was like the bathroom and the hallway, and like that's just an insane amount of work just going back over it over and over and over again.
yeah, yeah, taping and mudding is, and it's an art in itself because
Yeah.
if you don't tape and mud correctly, then you paint, and then you're gonna look at it and go, "Darn it, I got to redo this someday."
All my
And
stuff was overhead, and so I was like straining my muscles this way. But yeah, I mean,
oh man,
a garage isn't that bad. You don't really need to paint it after you mud it if you
no,
don't want to.
no, just
Like,
slap the stuff up there and call it good. But
yeah,
yeah, and then you got to deal with the weather. So if you have an open, uh, you know, cabin and with your truck
yeah,
bed, then you got to make sure it's not on a rainy day, and sometimes it'll sneak up on you.
yep, yep, yep. Oh, hey, when did you all show up? Um, well,
All right.
that'll be our cold open there. We're going to talk about panel layout this weekend instead of uh, home improvement. Um,
Different
so
kind of panels, but
different kind of panels, different kind of panels. So we're gonna be kind of showing you what not to do first. This is our nightmare scenario right here.
yep.
Don't do this. Just don't.
Ouch. Yeah.
Like, um, clearly this is amateurish, and it doesn't assist you when you're trying to troubleshoot anything. Like, there's all kinds of problems here.
No, this is easy, right? It's just as like the back of our computers. Most of the time, if we're connecting new devices, we're just routing the cable wherever, doesn't matter, plugging it in, and as
Yeah,
long as I get our new device working, then we're
or,
good to go, right?
or your
Um,
stereo system, or your
yeah,
television, your entertainment center,
yeah. Most of us don't want to look back there, right? And
no,
that's there's a reason why.
yeah,
And
there's a
but
couple of
there's
things.
also
Go
go
ahead.
ahead. There's also a reputation aspect. If
Yeah,
this is the kind of work you leave behind, eventually, somebody's either got to fix it or you might have to come back and fix it. So
yeah, yeah, and a lot of people suffer under this notion that like, well, I'm just going to leave everything dangling because if I have to chase wires, I can do that rather than tying them up into bundles where I can't chase wires. We talk about this in IMO, where chasing wires is literally the last thing that you should do, and yeah, you shouldn't need to chase wires. That's why you've got a multimeter.
exactly,
So
yeah, not a good visual and not a fun way to start the day off. If you have to show up and deal with this, you open that panel up
yeah.
and this is what you find.
And there's
It's gonna
also
be a
something
long
that we
day.
also have to keep in mind when we're dealing with things like this. We want to be very conscious about what wires we're routing next to what other wires. Because if we've got something that is going in, like if we've got a bundle of wires that's going and powering like a three-phase induction motor, that's going to be a significant amount of power and a significant amount of induction that could be inducted onto other cables. In particular, we got to worry about cables that have analog signals on them,
Yeah.
because noise
Mhm.
in them is going to offset the measured value that we see in those signals.
Yeah, and then you'll have end up with mystery faults that you can never track down.
Yeah, and chasing the wires won't help you there unless when you're chasing those wires, you start setting apart that high power AC away from the other one. But that's something we'll talk a little bit more about in the slideshow that we do on power versus signal. But yeah, don't do this. Long and short, this is crap. Don't do it.
Yep.
So when we're talking about laying out your components in your cabinet, here's some general tips that we want you to follow. You want to use cable track between each DIN rail, um, and that is so that we can run things between that. So you may be running something just straight across to a component straight down below it, but you want to put that extra cable that you're going to have there because you're going to cut the wires long. We'll get to that in a second, and make sure that everything is lined up and nice and neat. You want to separate voltages for the reasons that we just talked about in that mess there. Induction is big. You also want to kind of know whether you're dealing with, like when you're testing with a multimeter, it's fine to do a two-handed testing with 24 volts, but if you're doing that
Hmm.
with 480 volts, that's bad. When you're dealing with 480 volts, you want to be putting the ground and attaching the ground permanently and then using one hand. Put the other hand behind your back. Um, that way you're
Yeah.
not hugging a circuit because hugging
Yeah.
electricity is bad.
Yeah, or wear a rubber glove on your non-working hand.
Yeah,
That would,
that's
that's
another
kind of a
that's another one.
yeah, it's
Yeah,
dummy proof, and
yeah.
so, but yeah, you definitely don't want high power circuits in along with your low volt. Um, yeah, it creates a bit of an issue there,
You're going
safety
to
wise.
spend 90% of your time chasing down low voltage signals. You're you're going to test your high voltage ones first, and if you keep them organized and separated from each other, that makes that job a lot easier. It helps you be safer along the way. You want to let the connection of the components dictate the layout. And this can mean a little bit about what we were talking about separating voltages. For instance, if you've got a VFD, that's going to be attached to AC power, and then it's going to have AC power coming out of it. So you're going to want to have that off to one side so that you are separating that from the low voltage applications. And then you're going to want it next to what you're going to attach it to, which is going to be the PLC that's going to trigger the program on that. So let those component connections really dictate what components you put where. Um, Wire management.
Yeah.
The cable track, and we'll get into cable track and wire management as a separate topic. But the cable track that you have can hold plenty of wires, and you can hide the extra length of that wire in that cable tray. But if you have to rewire something, you don't want it to just enough for it to stretch one length, you know? You want to be able to take it to multiple points in there. A general rule of thumb I would say is you should have whatever length that you cut should be able to reach almost any terminal within the cabinet.
Yeah, yeah, you
Uh,
definitely don't want things to be that tight. There's going to be vibration. There's going to be other things that are going to slightly cause some kind of strain or movement with those cables.
yeah,
Last thing you need is things coming out, or just not having enough cable where now you have to uh, remove that one and reroute a whole new set of cable just for maybe a add-on that you did, or maybe a modification that goes in that system.
yeah. Cutting the wire should be the last thing you do before making the connection, and making sure that you have extra is key. Uh, then with circuit organization, using terminal blocks, using the color coding on the terminal blocks, using labeling on the terminal blocks will help you make testing easy in your panel. So it's a great way, like, if you're not like, you can get away with some very simple systems without using terminal blocks, but most of the things that we do are complicated enough, and certainly on these systems that you're working on now, that's on the cusp, but it's definitely complicated enough where using terminal blocks will be helpful.
Yeah, you want to make it just easy for your colleagues to come in and do work on a panel that you've built. You don't want to make things confusing or have them have to scratch their heads and try to make it difficult for them
Yeah,
just because you wanted to take a shortcut and not color code things, or organize things properly. So just keep
yeah,
that in mind, that you're not the only one that's going to be in that panel.
yeah. Well, the rest of what I've got on this slide deck is just some examples to kind of talk through, and we'll point out some things on them. We'll see Carlos' reaction on these. Um, Here we have a system that doesn't have any terminal blocks. Um, there's a couple of things I want to point out on this one. There's no terminal blocks here. There's some circuit breakers, there's some contactors and items going from there, and then there's operators that are out on this.
Hmm.
Um, this might be a bit of a nightmare to test on as a result of not having terminal blocks on it, because this is more connections than I would want on something not having terminal blocks. And but one thing that is a good indicator here that I don't think I got in the shots of other systems is this sort of thing. When you've got things that are on the door of your enclosure, you're going to want to take all of those connections over to the hinge side of the panel, and you're going to want to bundle them up when they make that jump over from your cable trays over to connecting to components you've mounted on the panel, like on the front door panel. So
So you're saying we wouldn't want those strewn about along
no, you
the
don't want to have like when you open the cabinet, you don't want to have like multiple dangly wires that just stretch out like a spider web when we
yeah,
open the door. We want
yeah.
to and that's why you bring it over to the hinge side so that the movement that it needs to make when that door opens is a lot less. If you if you have all those connections over on the other side, it won't work. Like it'll limit how far you can open the door, and it'll just be a wire that's in the way of you working with anything. So always carry anything that's going to the like anything panel mounted to the front door. Um, Always carry that over to the hinge side and make one bundle, maybe two bundles if you've got a lot going on the front door. Uh, that's all gathered together and isn't going to get caught in the door. So
Exactly.
uh,
Yeah, you definitely don't want it because as soon as it gets caught in the door, you're going to start chewing on that insulation, and then eventually you're going to get to bare metal or the shielding of the cables, and you're going to
and the
run into
whole
problems.
enclosure is grounded, so it's going to just short straight to ground, whatever you do.
Yeah.
So
Yeah, and the other thing is, when you eventually end up wiring your panel up, you definitely don't want to have the door open a certain amount and then wire it to that, degrees of that door being open. You want to make sure that there's enough slack in order to have that strain relief if you open that panel all the way. Because what'll happen is somebody else is going to walk up and open that panel completely as far as they can open that door. And if you don't have enough slack in there, they're just going to pull and create tension on those cables, which, depending on how much slack you have and strain relief,
yeah,
could be a problem after so many times of opening that door or
yeah,
that
good
panel.
point. Why are these when your door is as open as it can be? Um,
Yep.
so yeah, cool. Let's move on to the next one. This is a pretty good layout. Um, the one nitpicky thing I would put on it is that we've got our terminal block array here, um, and that doesn't have anything. It doesn't have cable track in between the two of them. So
Yeah, and that could have been a couple different reasons, right? It could have
yeah,
been, maybe they ran out of room at the end there, and they're like, man, how do we squeeze that in there, especially with,
yeah,
all those ribbons coming out of
yeah. You're fighting for
PLC there.
space constantly.
Yeah,
But all in all, like this is a pretty neat one. Like if we compare that to our nightmare scenarios that we showed first, this is
yeah,
really good, really good. But that
right.
terminal block right there, that's where you do 99% of your testing. Um, and then you may resort, if you've got a fault, then you may chase that back to another component. And if you've got it labeled well, figuring out where that is, you don't have to chase the wire to where that component is.
Yeah, and you can design this, you can CAD this up, and that drawing that you might have, that design might look perfect, in virtual space, but once you start putting actual cables in there,
Mm,
you don't account, you miss accounting for one, variable or one, particular cable that happens to be thicker or, whatever that may be. And then now you're limited on space. So then you already bought the panel, you already have all your equipment. Now you're going to have to figure it out.
yeah.
So just keep that in mind. You're going to have to be a little flexible, but, obviously if it comes to the detriment of how this thing will actually work, if it's going to be unsafe or et cetera,
Yeah.
then might have to make a change of plan there.
Yeah. Another thing to keep in mind here is that your DIN rail, right? That isn't just the dimension that you need for in between your wire track. You need to have different components are going to be different heights around that. So like everything lines up straight in a row, but some will be like this, some will be like this around that center point of the DIN rail. And so it's a good idea to kind of mock up where on the DIN rail your components hit so that you don't put your cable tray in a place that makes it impossible for you to mount your components on those systems or on those DIN rails. Did what I say make any sense?
Yeah,
Okay, okay,
definitely did.
okay. Um, so yeah, and this kind of shows you exactly what I was just saying there on a DIN rail. So you've got terminal blocks, so they take up this space, and then you have larger relay blocks here that take up more space, and then your PLC would take up even more space, and it'll be above and below. So in order to figure out where we mount our DIN rail, where we mount our cable track, we kind of need to see how our components fit on the DIN rail in order to give us the right amount of space between that and the cable track that's adjacent to it.
Yeah, and also make sure that when you're mounting your DIN rails and when you're punching holes in these cabinets, take some proper measurements. Take the time to make sure you measure twice, cut once. That way you don't have a bunch of holes in your panel, and the other end would be that you'd have you know incorrectly aligned DIN rails, and they might be off kilter, whether
Yeah.
it be horizontally or vertically. So because
Make sure they're straight,
make sure they're
straight
straight.
horizontally, or
Yeah,
it can they can actually also be vertical too. We'll show a
yeah,
picture of that a little bit later. Um,
yeah,
this shows a good deal of the variance in height between components that are DIN rail mounted. They're all mounted to the same, size DIN rail. But you can see that these components in here, these are drives of some sort. We can't really tell if they're VFDs or maybe servo
yeah.
drives. Probably servo drives, considering there's three of them. But both of those components need some space around them. And it's also important that we keep in mind with some components, there is a thermal management component to them, particularly variable frequency drives and servo drives. They generate a lot of heat when they're amplifying the signal to go out and drive the motor. And so they are going to have specifications about where you can mount stuff, usually above it. A lot of them are passively cooled. Some of them
Hmm.
have powered fans on them. And so they need that ventilation around them. And that's going to be in the documentation for those components. Make sure that you're following that documentation for the components as to where you can mount it um, in your enclosure. They're going to give you setbacks essentially from the sides, setbacks from the top, setbacks from the bottom to allow for proper airflow to cool the component.
Hmm.
So
Yeah, really important.
this one really that we see here, this is an excellent layout here. We can see we've got cable track in between each DIN rail, and we've got like really nice, organized, and looped together. Just look at how they run these coils of the connections that need a little bit of space in order to get into the cable tray. Um, zip
Everything's zip
tie.
tied perfectly. Yeah,
Yeah, everything's zip tied perfectly. Zip ties are your friends. Zip ties are always the last thing you do. Don't do it until you've tested it, but do it.
yeah. Yeah, and just be mindful when you are using the zip ties and you're cutting zip ties. Make sure you know where uh, diagonal cutters are cutting because you don't want to cut anything that you've already set up there. And then you're just gonna have
Yeah,
to
don't
rewire something.
don't cut the wire along with the zip tie.
No,
Yeah,
it's happened. So
it's
just
happened. I think
yeah,
pretty much everybody makes that mistake at some point.
yeah.
But yeah, so so this is an example of where you can have DIN rail and cable track mounted vertically. Um, and you can absolutely do this. It really depends on the components that you're putting on that, right? Um, we mentioned thermal management. Some passively cooled devices use a heat sink and they rely on airflow going a certain direction, and it's due to the fact
Hmm.
that heat rises. Don't mount any of those components on a DIN rail going this way. So that's an important caveat there. And then also another thing is how tightly it fits against the DIN rail. You don't want them to slide off down towards the bottom with any vibrations or things like that. If they're very tight fitting DIN rail components, mounting them vertically is possible. Or if they're very lightweight and still tight fitting, that's fine. But anything that's got a decent amount of mass, you don't want to mount it vertically. And you'll note here that they didn't mount their PLC modules that way. It's only terminal
Right.
blocks, which are relatively lightweight, that are going vertically here.
Yeah, gravity is unbeaten, so it will win every time,
Yeah, yeah.
or undefeated, I guess I should say.
Um, yeah. So there's more to come on these subject matters. We're going to have a separate video later on circuit organization and on wire management that'll go a little bit more into depth on some of these practices. But I wanted to give you kind of a photo overview of what we're shooting for inside these cabinets. Um, yeah. So there you go. That's all we've got for you for this one. We'll see you in the next video.
All right, we'll see you then.